So, thank you very much for inviting me to this great event here at UN. So we have here very beautiful visual support of my talk. So if you want to see what I'm talking about, you have to move maybe to the front right corner. I mean, it would be difficult from over there, but you're very much invited to come to the front. So there is a good reason to see the content. And here there are also some nice videos that you will miss from the last row. So today I will try to give you an overview, first of all, on our projects at AIT, and in the second part on some planning methodology that we developed in the past at different locations at AIT Zurich, in Singapore, and also in a project in Addis Ababa in Ethiopia, where I want to show you a case study how we applied these methods. So first of all, there is something where we started with a few years ago. That's urban simulation tools and methods that are able to simulate how settlements, how urban fabrics will evolve over time. This resulted in a project in a software tool that is developed at AIT at the moment and also applied for the South American Development Bank called Urbanica. You can use this tool to specifically evaluate and simulate urban planning scenarios. So dependent into which you want to invest your money, into infrastructure or something else, the system can predict or simulate the effects on your investment. Often you miss the data for doing this kind of planning. Therefore, we have also a module or the project at the AIT that uses Earth observation data to provide the basic data of settlement structures. If you think on South America, on Africa, there is not such a great thing like OpenStreetMap that is up to date. Usually you don't know the current state of settlements there. Therefore, you can use this automatic evaluation of Earth images to have a good ground for your planning. Another project is so-called scenario comparison, where we compare the impact of different strategies to transform your city concerning the kind of energy and the money you have to invest, and when you get back the profit from your investment and so on. So there is another system that we developed there. So this is was just a brief overview on some projects at AIT. Now I want to switch to a methodological basis of urban planning, how we try to implement it. That's called cognitive design, cognitive urban design computing. The idea is that we combine newest technology from artificial intelligence that can support the human designer and his cognition in a way that urban planning becomes more efficient. So we want to combine the best of two worlds. So I can do many things that a computer may not be able to do in the near future at least, and the computer can do many things that I can't do that efficient. So just to give you a context, the idea is that we use a method that is called backcasting. That's somehow a planning methodology where you define the kind of outcome that you want to have in the end, and the computer system helps you to find the path to reach this kind of state or outcome or planning result that you want to achieve. So now probably the people in the last row will have difficulties to see what's shown here. That's the first case study that we've made recently in Singapore, and there they want to transform an area near the harbor, or that is used as a container terminal at the moment, and they moved the container terminal to another place and want to replan this area as a kind of residential and business district. So here you can see certain steps that where we applied this tool. First is to get the data automatically and then to generate planning proposals in a very fast way. So that's a real-time video, so you can create these scenarios just by changing the restrictions, the requirement that you have for a planning, and you get a kind of geometric result, a master plan immediately. So you can play through all your possibilities that you may test, and you can get here some very quick so-called prototypes for master plans. You can also have a lot of measurements in the background, because since we have a digital model, we can measure all kinds of key performance indicators. So since we can produce a lot of planning proposals with this method, there is another technology that we developed where you can somehow explore what we call the design space. That's somehow all collected options that you're interested in, but at a certain moment in time, especially in the beginning of a planning, you may not decide which one is the one you're interested in or the best one for your planning. So you can navigate through this design space just by exploring various options, looking at their performances, and deciding what you want to explore in more detail. Another aspect is that we use big data to predict the effects of certain plannings. So if we have data for an existing, let's say, industrial area, we can analyze this area, how well it works, and what may be some problems. And correlating it with the geometry and the street network, we can use this information to predict if a new planning will work or will have similar problems as well.